Thank you, sir. Okay, so I'm a walker, and I grabbed the lav mic. A little bit of background on me. I was integrator for 24 years in the utility industry, and along 9/11, there was a catastrophic event in our country. The utilities took all their jobs in-house, and because of security reasons, and I couldn't get a job, couldn't find a project. So I would call what I said, join the dark side. And I came over to the utility. I was automation engineer with Washington Gas for 5 years, automating their processes out there, and then took over the job as the supervisor and manager of automation and control. A little bit of legalese. Washington Gas, you'll hear some vendors and products come out of my mouth. Washington Gas does not necessarily endorse or recommend these vendors or products. If you want to ask me about it later and for me to give my personal opinion, I will give it to you loudly and often. Also, I'm Craig Lightner. That was Craig Resnick. He's the pretty one. Okay, we're talking about IIoT. Washington Gas actually will be a good example of a successful deployment of IIoT. Back in 2009, the FBI came to Washington Gas and said, we found some indications that you've been compromised. At that point in time, Washington Gas, the ICS, Industrial Control System, was actually part of the Active Directory of the corporate because of efficiencies, obviously. They didn't want two systems to maintain. Sure enough, they looked at it, there was a SQL intrusion. People were monitoring our traffic. So right that very afternoon, we isolated the systems. We put a standalone Active Directory into the ICS infrastructure, and it took off from there. We've migrated and proceeded. A little bit of background of what we cover. When we said Washington, this is Washington, D.C. I don't expect you to see that or know what's going on there, but that's a bunch of towers. Washington Gas owns and operates its own microwave system through the states of Maryland, West Virginia, Virginia, and DC. We rival Verizon for microwave capabilities. We use a microwave backbone to contain all of our data for the corporation, and that's just a drill-in. We put together an infrastructure. Notice all of the rings. This is the microwave rings. That is so no single point of failure on our microwave will take down our data collection. We also use this same system to house our LMR, land mobile radio. So all of our communications that take place within Washington Gas come across the microwave backbone. You do see some spurs on there. Those are just radio spurs for coverage. All of the main for SCADA data collection is redundant. So a little bit about gas industry itself. In the gas industry, there's wellhead production, there's transportation pipelines, and then there's LDCs. Washington Gas is an LDC. We take pressure off of the high transportation pipelines and provide lower pressure gas to all of our constituents. A little bit about the process, because this leads into our IIoT convergence. Take note, you have some very high pressure transmission pipeline coming in. It goes through redundant runs so that we can meter from the transmission pipeline to our constituents. We then heat the gas and we control the pressures going out. We also add odor to gas. I don't know if you know, but natural gas would asphyxiate you before you would know it was there if it didn't have odorant in it. So we put the smell in it. The reason that you heat up gas, when you cut something from a very high pressure down to a low pressure, it's an exothermic reaction. You've experienced this with your propane tanks at home. In the shoulder months, you've seen it ice over in the spring and the fall when you use it. It's going from high pressure to low pressure. If we didn't heat it, it would freeze water droplets and your regulators at your house would freeze up and you'd go cold. So we keep it at 60 degrees going out. In this drawing, I wanted to just demonstrate the redundancy and the extra pipes that are in the ground. We do this so that, just like our communication rings, there's no central point of failure that we couldn't get gas to your house. Take note, in the background, there are also multiple stacks. We have multiple line heaters so that in case of failure, we have a backup. Our product, a really great part about natural gas, is also our energy source, so that when you would go dark and you lose commercial power, we use generators that we run off of the natural gas to keep our gate stations running. Also, long before there were electronics, there were pneumatic controllers. All of our gate stations have pneumatic controller backup that in case of going dark and the electronics die, we can continue to serve our customers. And that's done by making sure that we don't overpressure the line and we don't underpressure the line. Pneumatics take over. Even if a PLC should go rogue and decide that it was going to try and put more there or less there, pneumatics take over and we'll make sure that that doesn't happen. In addition, Washington Gas specifically went out and added an extra system that goes out and monitors the pressures around the area. This is so that if somebody were to actually able to compromise our main ICS system, we've got what's called tattletales out there that, above and beyond the industrial control system, would be able to tell us what was going on. So there you go. There's our area. That's what the operator looks at. He's sitting there maintaining all of that high-pressure system. Now, we take cybersecurity very seriously. As I like to say, the president sleeps in our backyard. This is Washington, D.C. There is a 300-pound pressure line running down the length of the mall. And the mall, if you're not familiar with Washington, D.C., is that green area that's in front of the Smithsonian's that run between the Capitol and the White House. If we were to have a catastrophic event there, Washington Gas would not be able to recover from that. So how do we put together our system? Obviously, we use the current cybersecurity methods that are in place. We actually had DHS come in and participate in the design of our infrastructure for converting this over. Now, you've heard my background. I'm OT, and I thought at that point in time, IT was a bunch of pinheads that didn't know what they were doing. Sometimes I still think that. But they were intimately involved in this deployment. As part of what we did when we put this in place, our group that manages the PLCs and the controls and so forth, we took over and kept the applications. We handed over to IT the maintenance of the Windows and the patches and all of that other IT stuff. So that they are part and parcel. And as it turned out, when we did this deployment, we actually have dedicated IT staff that are dedicated to this system, as well as the 7 dedicated personnel that maintain the control portion of this. I talked a lot about redundancy. You heard me say it over and over again within the physical portion of our pipeline. We had redundancies on pipe, on heat, and on control. Why would I put together a system that didn't also have that same redundancy? It would make no sense. So the core here, we use servers and HA, high availability switches and routers on any core communications and control. Our communications across the microwave network are not shared. We did put several VLANs on there for some corporate traffic, and I'm really proud to say that IT traffic is less priority than ours. So that is how we put it together. And I did tell you there's no touch to the internet, and yet you see some of those on there. We, at the outer edge, have things like WSUS and SEP, where we're using the communications to get our patches and so forth. That's on the outer edge. There is no routability to the intercore, and how we get that across is SneakerNet. Completely isolated. This particular one represents, we're in Springfield, Virginia. This is primary in Springfield, Virginia. That is the secondary up in Frederick, Maryland. The geographical area that we actually cover, Frederick, Maryland is probably the furthest north, and Quantico in Virginia is the furthest south. That's only about 100 miles. But our east to west, it's from Romney, West Virginia, where we have gas wells, storage wells in the ground, all the way to the east, where we have Cove Point, that's on the Chesapeake, basically. That's about 300 miles wide. So that's the territory that we cover and maintain. A little bit about the gas companies and why I pointed out the 3 different types. Did you know that wellhead production and LDCs have no cyber regulations whatsoever? There's none out there. And that's important to realize because the transportation pipelines are regulated by DOT. These factions are actually vying to get regulations for us, put regulations in place for us, for our LDCs and wellhead. That last one there, American Gas Association, they are our lobbyists on the Hill that are trying to make sure that the regulations that come down are reasonable and prudent for LDCs and pipeline. And I bring that up because what's out there in the world, there's everything from 50 people, driving trucks around well sites and monitoring them, to huge energy conglomerates that not only do they maintain and control the energy that's in their area, but they've started to actually outsource and take over the control of other gas companies and so forth that can't afford to put that kind of infrastructure in place. So it's not uncommon to find an energy conglomerate that's controlling something in California, Texas, and Virginia, and they're all doing it from some central location. Very prevalent. Not all companies have embraced the security that we have at Washington Gas. So challenges, same challenges everybody else has faced. Handling the upgrades, a certified supply chain. Yes, we worry about the equipment that we bring in-house, and of course the support mechanism. That's kind of why some of the high availability stuff that we've put in place is there, because we depend on that support. In this isolated world that's out there, or at least thought portion of it, we struggle with that internet access. As part of when I showed you the infrastructure that we put in place, our reports and so forth actually go out through a diode, as it's called. It's a one-way transfer. So in order for us to email reports, we don't have an exchange server in the infrastructure. That's just not reasonable. So we send reports out through a diode that cannot route back into the infrastructure. Those are some of the precautions we've put in place. So with that, we'll pass on to the next one. Thank you.